Okay, welcome to section 2.3, which deals with solving equations that have variables and constants on both sides. So basically, that's kind of what we're doing. We're going to solve equations with constants on both sides, which we have been doing. Solve equations with variables on both sides, that's new. And then solve equations with both variables and constants on both sides. So let's get started. So here are some examples of equations that have variables and that have constants on both left hand and right hand side. Because when I say sides, I mean sides of the equal sign. Okay. So I'm sure I've said this before, but just in case, when I say, left hand side, or if I do LHS, I'm talking about literally the left hand side. And then this side would be the right hand side, or RHS, right, of the equation. Okay. Anyway, you don't need to that's not on a test or anything. That's just so that you understand what I'm talking about. Okay, so first thing is our goal is to solve for x. So we need to get rid of the constant term. So we would subtract both sides from, in this case, it's a positive 8, so we want to get rid of it. We subtract 8 from both sides. To bring this down, we get 7x is equal to, and this is going to be, they're both negative, so you add, and then we get 7x is equal to negative 21. In order to solve for x, we need to divide by 7. And then we get x is equal to negative 3. Okay, so then here, so that's one. So you see that's a 2 steps. You subtract both sides and then we divide it. So in this case, we get rid of the constant. Okay, we cross that out on the same side as a variable. We bring this down, bring down the equal sign. Negative 8 minus 4 is negative 12, then divide. Okay, so what did we do? The 2 steps, step 1, subtract, or in other words, maybe the better way to think about it is to get rid of the constant. So get rid of constant term on the side where the variable is. Okay, so, and then 2 divide. So that's kind of the theme of this type of equation. So you kind of see where we're going. So in this case, the 9 is in the way, so I'm going to do the opposite, which is adding. That cancels this. I bring this down, that's 8y. Bring down the equal sign. 31 plus 9 is 40 today. Now I look at this, if this was I look at this line only, and I see that I need to divide by 8. So that's y is equal to 5. Okay. So here we have 3m minus 8 is equal to 19. Getting rid of the 8, I'm going to add 8 to both sides. Bring down the 3m. 19 plus 8 is 27, and then divide by 3. So then m is equal to 9. Okay, so let's do a few more examples. Now these equations have variables on both sides, so this is a little different, okay? So we still subtract, but the idea in this case is to combine the variables or get variables on one side, right? So so we want to, some people think of it as moving, but the only way that you can move it is you need to use the addition and subtraction property, okay? So let's say I want to get all the variables on the left-hand side. So I'm going to subtract 8x because it's positive from both sides, okay? So that's going to cancel out on the right-hand side. And on the left-hand side, 9 minus 8 is 1x. And then I'm going to bring down this minus 6. And that is it for this problem. Okay, so here I'm just going to subtract the 5n. So notice that I'm subtracting it from the side that has two terms. This one only has one term. So minus 5n, that cancels. 6 minus 5 is 1n, and then bring down the negative 10, and that's it. So these are one-steppers, right? So in this case, I'm going to add 7c to both sides. Okay, and that cancels out. Negative 6 plus 7 is 1c positive, and then I bring down this negative 1. And that's equal, c is equal to negative 1. So here, I'm going to move the 5y, because the goal is to get it by itself. So I subtract both sides by 5y. I'm going to bring down this minus 9. 8y minus 5y is 3y. And then divide both sides by 3. And I'm going to get y is equal to negative 3, or negative 3 is equal to y. This is the same thing as saying y is equal to negative 3. Okay? All right. So let's continue. Now this one has variable and constants. So what is the goal? The goal is that we want the x or u or whatever the variable is equal to some number, right? You know, like 6 or 10 or whatever. So in this case, we're going to have to do some kind of manipulating. So let's say we want the variables to be on the left. That means I'm gonna technically, quote unquote, I'm gonna subtract 6x from both sides. Why do I do that? That's gonna get rid of this, and I'm gonna rewrite everything else. Okay, so bringing this down, 7x minus 6x is x, plus 5 is equal to, and then you bring down the 2. Okay, and now I have this. Think of this as a new line. X plus 5 is equal to 2. So to solve for x, I'm going to subtract 5 from both sides. Okay, so that's gone. And then I bring this down and I get x equals negative 3. Okay, and that is the solution to that problem. Now let's try this one. I'm going to subtract 6x from both sides. And then I'm going to, bring this down here. I get 12 minus 6, that's 6x. Bringing down the plus 8 and bringing down the 2. So now I have 6x plus 8 is equal to 2. So subtract 8 from both sides. Why do we do that? It's because we want to isolate the x, right? So that's going to get rid of this. I bring this down. I get 6x is equal to 2 minus 8 is negative 6. And now to solve for x, I'm dividing both sides by 6. I get x is equal to negative 1. Okay. Now here we see that we have a parenthesis. So let's go ahead and distribute the 2/3. Okay, so what that is, that's 2/3 times 6m. I'm going to put that in parentheses. Minus 2/3 times 3 is equal to 8 minus m. So I'm going to do a little bit of simplification here first, okay? So 3 goes into 6 twice. This is going to be 4m minus. These 3's are also going to cancel out. So that's going to be 2 is equal to 8 minus m. So what I'm going to do is I'm going to add an m to both sides here. And that's going to cancel out. 4m plus m is 5m. Bring down the negative 2 is equal to 8. So then to solve for m, I'm going to add 2 to both sides. And then I'm going to rewrite here. Sorry about that. This is going to become 5m on the left-hand side. I'm going to write that right here. Okay, so 5m is equal to 8 plus 2 is 10. So this is, 5m is equal to 10. So then I'm going to rewrite that here. So divide both sides by 5, and we get m is equal to 2. Okay, so let's do that here. We have 1/3, so let's distribute that. 1/3 of 6 is just 2. So 2u plus, and then 1/3 of 3 is 1, is equal to 7 minus u. So now I'm going to combine the u. Sorry, it keeps doing that. So plus u. So that becomes 3u plus 1 is equal to 7. So minus 1 minus 1, I get 3u is equal to 6. Divide by 3, and u is equal to 2. Okay, great. Sorry about that. Okay, so what are some strategies here? So first of all, you have to choose a side to be the variable side, okay? And the other side will be the constant side. So then we need to get, all the variable sides to what, we decide with whether we want it to be the left side or the right side, okay? Then we collect the constants to the other side, and then we make the coefficient of the variable equal to 1, either dividing or multiplying, okay? And then if you want, you can go ahead and check your solution by substituting into the original equation. So in this case here, we have 8n minus 4 is equal to negative 2n plus 6. So what I want to do is I'm going to try to have the variables on the left-hand side. So I'm going to add 2n to both sides. Okay, and that's going to cancel this on the right-hand side. 8n plus 2n is 10n minus 4 is equal to 6. Okay, and then I have 10n minus 4 is equal to 6. So to isolate the variable, I'm going to get rid of the constant term by adding 4 to both sides. So 10n is equal to 6 plus 4, which is 10. Then divide both sides by 10, I get n is equal to 1. Okay, so there you go. So now we have here 7n minus 3 is equal to n plus 3. I'm going to subtract n from both sides. So notice that I write it directly underneath the variable. 7n minus n is 6n today. Bring this down. And I bring everything else down, right? So this is a positive 3, so just 3 like that. And now I need to get rid of this minus 3, so I'm going to add 3 to both sides. And I get 6n is equal to 3 plus 3 is 6. Now I want to get rid of the coefficient of 6 that's next to the n, so I divide by 6, and I get n is equal to 1. All right, so that is that. And let's try the next one here. Super fun examples. So we have a couple more, and I want you guys to try this out. So you can also, this is a good example now to show you what you can have the right-hand side have the variable or the left-hand side. So in this case, I noticed that the right-hand side has 13 A's and the left-hand side has 7. So I'm going to quote unquote move the variable to the right-hand side by subtracting 7A from both sides. Okay, so here I have that cancels out. I bring down minus 3 is equal to 7A. 13A minus 7A is 6A plus 7. So then subtracting 7 from both sides, I get what? That cancels out, and then I get 6A on the right-hand side, and then negative 3 minus 7 is negative 10. So divide by 6, and I get 10 over 6, which reduces to negative 5 over 3. And that's your answer, 5/3. A is equal to 5/3. Okay, so this case, let's go ahead and subtract both sides by 2A. So that's just to show you that you can, go either way. And usually it's better if you subtract larger by the smaller so you don't deal with negatives, okay? But that's fine if you deal with negatives too. You should still get the same answer. Okay, so I bring this 6A minus 2A is 4A. Bring down the 18, that's plus 18. So now I subtract the 18 from both sides. And I get 4A on the right-hand side. And negative 2 minus 18 is negative 20. So now to solve for A, I divide by 4. And I get A is equal to negative 5. Okay, or negative 5 is equal to A. Okay, so in this case, I'm going to subtract both sides by 1/4 of an x, right? Cancel, cancel, bring this down. Minus 2 on the right-hand side equals, bring down the 6, positive 6. 5/4 minus 1/4 is 4/4, which is the same as 1, but that's okay. You could write 4/4 x. That's fine. That's the same. So then I need to just get rid of, that's just, 1x. And then I'm going to subtract both sides by 6 to get rid of that constant. And I bring down the x, and I get negative 2 minus 6, which is negative 8. Okay, so then finally here, you have 7/8. So to get rid of this 1/8, I'm going to add 1/8x to both sides. Minus, and then I'm going to cancel out the right-hand side, bring down the negative 2 on the right-hand side, bring down this 12, minus 12. 7/8 plus 1/8 is 8/8, or that's the same as 1x. Okay, so then I'm going to add both sides, 12 to both sides, and that's going to cancel this constant term out on the left-hand side. And I'm going to bring down the x. That's going to equal negative 2 plus 12, which is a positive 10. Okay. So you can do the same thing with decimals. Okay, so here we have 7.8x plus 4 is equal to 5.4, x minus 8. So what we would do here is we would subtract 5.4x from both sides, and that's going to cancel here. And then 7.8 minus 5.4 is 2.4x. Bring down the 4, bring down the negative 8. So basically, it's positive. I'm bringing down everything else. So subtract 4, subtract 4. Okay, and then bring this down. 2.4x is equal to negative 12. And then I just divide by the coefficient of x, which in this case is 2.4. So that's going to be negative 12 divided by 2.4 positive. So that's going to be a negative answer. Okay, and that's going to just be 5. Okay, so then here, that's your answer. So then here we have 1.4, so I'm going to add 1.4x to both sides. That's going to cancel on the right-hand side, and this is going to become 4.2x. Then bring down the positive 12, bring down the equal sign, bring down the negative 9. Okay, there you go. Then to solve, isolate the variable, I'm going to subtract 12 from both sides. Okay, that's going to cancel out on the left-hand side, bring this down. 4.2x is going to equal negative 21. So then I divide both sides by the coefficient of x, which is 4.2. So you see, then you get 21 divided by 4.2, and that's going to give you 5 also, but it's going to be negative 5. Oh, this was also negative 5. Sorry about that. So there you go. And that is it. So just so you can see that decimals, the way that you would handle decimals or fractions or whole numbers with variables, it's all the same process, okay? So just don't be afraid of it or anything, okay? So you're doing great. Okay, so that's it for this section. You can do odd or every other odd. If you need more or less practice, up to you. Honor system. Good luck, happy studying, and I will see you in the next video.